Alright, so let's start with some other problems. Only two forces act on an object mass of 3 kilograms as in the drawing. Find the magnitude and direction relatively to the x-axis of the acceleration of the object. Now, according to Newton's second law of motion, the acceleration of the object is net force over mass. The net force is the sum of all the forces in the x and in the y. So let's start by looking at all the forces. In the x, we have 40 newtons, but we also have a second force found by using trigonometry of 42.4 newtons. In the y, we have a force of 0 degrees, and then a second force of 42.4, also found using trigonometry. Now, when you add them up, you see that the x component is equal to 82.4 and the y component is equal to 42.4 newtons. Therefore, you have to use Pythagorean theorem to find the magnitude of the net force, which gives you 92.7 newtons. Knowing the net force and your mass, you can find your acceleration by dividing, and you see that your acceleration is equal to 30.9 meters per second squared. Now, in order to find the direction, you have to draw out your triangle, put in the x. You have to find that your x force is 82.4, your y force is equal to 42.4, and when you draw that triangle, you have to find theta. Now, using tangent inverse, you see that your theta will be equal to 27.2 degrees. Now, let's look at another problem. At an instant when a soccer ball is in contact with the foot of a player kicking the horizontal or x component of the ball's acceleration is 810 meters per second squared, and the vertical or y component of its acceleration is 1,100 meters per second squared. The ball's mass is 0.43 kilograms. What is the magnitude of the net force acting on the soccer ball at this instant? Now, let's start the problem by drawing a free body diagram. You know that the vertical acceleration is 1,100 meters per second squared, and your horizontal acceleration is 810 meters per second squared. You need to find the magnitude of the acceleration. Therefore, using Pythagorean theorem, you can see that your acceleration will be equal to 1,366.1 meters per second squared. Now that you have your acceleration, and you know that the ball's mass is equal to 0.43 kilograms, you use Newton's second law of motion to find that net force is equal to mass times acceleration, and you will get a resulting force, net force of 587.4 newtons. Let's look at a third problem. A rocket of mass 4.5 times 10 to the 5th kilograms is in flight. Its thrust is directed at an angle of 55 degrees above the horizontal and has a magnitude of 7.50 times 10 to the 6 newtons. Find the magnitude and direction of the rocket's acceleration. Give the direction as an angle above the horizontal. Now, to determine the acceleration, you need to use Newton's second law of motion, which says that net force is equal to mass times acceleration. However, you also need to consider that two forces act on the rocket, the thrust and the rocket's weight, which is equal to mass times gravity. So let's start the problem. You have your rocket. You have your mass of 4.50 times 10 to the 5th kilograms. When you draw your free body diagram, you see that your angle is equal to 55 degrees, and the magnitude of the force is 7.5 times 10 to the 6th. In order to find your complete net force, you need to consider that there's another force of weight. Weight is equal to mass times gravity. So your force, because of weight, is 4.41 times 10 to the 6th newtons. Now you need to separate your forces into x and y components. Your net force on the x is equal to 4.30 times 10 to the 6th. Your net force on the y is equal to 6,143,640 newtons, minus, you need to consider that on the y, your weight is pulling you down. So you need to subtract that force from the thrust of the rocket pushing up. So you do minus 4.41 times 10 to the 6 newtons. Using your x and your y, use Pythagorean theorem to find your net force. Your net force is equal to 4634964.9. And when you divide that by your mass of 4.5 times 10 to the 5th, you get your acceleration, which is equal to 10.3 meters per second squared.